the 2008 relative velocity. We're told on a particular day the velocity of the wind is xi minus 3j. Velocity of the wind, xi minus 3j. We're told x is an element of natural numbers. Just remember that at the end. And east and north, of course. To a man traveling due east, he's going in, that's west, he's going to Dublin, he's going that direction. The wind appears to come from a direction north a degrees west, and tan a is equal to 2. So let's just have a look at a sketch of that. So he's traveling in that direction, and the wind appears north a degrees west. Well, if we go north, then we have to go a degrees west. A is in here. That's going to continue down in this direction. A will be in here. My unit vector then, this is the velocity. The wind appears, the velocity of the wind relative to the man. It's coming down in this direction. So my unit vectors, my I direction is opposite the angle this time. And my j direction is adjacent to the angle along here. If you imagine y here and x here. So setting up the velocity of the wind relative to the man, be tan a is equal to 2. So let's put a in. 2 over 1, opposite over adjacent, root 5. So cos a is going to be equal to 1 over root 5. And sine a, 2 over root 5. So my unit vector for velocity of wind relative to man is going to be equal to, well, we don't have the speed, so I'm going to say u by the sine of a, 2 over root 5. That's going in the positive negative direction. Then minus u by 1 over root 5 in the I and j direction. We have the velocity of the wind and the velocity of the man. He's traveling due east. We don't have his speed, but then when he's traveling due north at the same speed, so we'll call that speed, we'll call it a, not to mix it up with acceleration. So the velocity of the man, in this one he's going due east, positive I direction, it's going to be a in the I direction, plus 0 in the j direction. So we can set up the velocity of the wind relative to the man is the velocity of the wind minus the velocity of the man, which we have in these terms. The velocity of the wind is xi minus 3j minus the velocity of the man, which is minus ai, and then minus 0j, which has no impact. So the velocity of the wind relative to the man we now have in terms of x minus a in the I direction, and then minus 3 in the j direction. So now can I equate my u over root 5 is equal to root 3? U over root 5, this one has to be equal to this minus 3, they're both minus, so we can say equals 3. So now I have a value for u is equal to 3 root 5. So now I have down here x minus a has to be equal to 2u over root 5. And I have my value for u, so x minus a is equal to, if I separate the 2 over root 5 times u, which is 3 root 5, x minus a is equal to 6. So I think that's all I have for this easterly direction. So now let's have a look at the northerly direction that we were given. When he travels due north at the same speed, so the velocity of the man this time is traveling due north, so it's going to be 0 in the I direction, plus we said it was a, so a in the j direction. The wind appears to come from a direction northwest. Do another diagram, then north b degrees west. So if I go north, but that's the same as before, isn't it? north A degrees west. Now we're north B degrees west, so it's coming from here, B degrees west. Let's continue then in this direction here. Give me a B in here. So again, this velocity of the wind relative to the man. The I component is going to be opposite B. So what do we have for the value of B? Tan B is 3/2. Just set up your triangle so as not to make a mistake. Opposite over adjacent, root 9 and 4 is 13. So the cos of A is your 2/√13. And your sine of A is 3/√13, which you can all see. You may be able to do it a little bit quicker. So then the velocity of the wind relative to the man in these terms, we don't have its speed. What do we call the last one? U. We call this one V. Let's call it V. Although we've got V's in the question, let's call it P by the sine of A. So that's 3/√13. And it's in a positive negative direction, minus P over, just check, yeah, that's the sine, and then minus P by the cos, 2/√13. In the J direction, we have the velocity of the man with 0y plus aj, so we need the velocity of the wind in this case, which we'll be able to work out. Velocity of wind, we were given x in the I direction and minus 3 in the J direction. So if we set up our velocity of wind relative to the man being the velocity of wind minus the velocity of the man, we're going to get x, the velocity of wind, my x component, minus 0 up above. So that's just x. And then we're going to have in the J direction, we're going to have minus 3 minus A in the J direction. And I've just done a bit on the frame for a plus. So where if we equate these, so we've got our 2 velocity of wind relative to man's. So x is going to have to be equal to 3p/√13. So that's another value for x, and we're going to have minus 3 minus a is going to have to be equal to, well, then all pluses then, minus 2p/√13. So what's the quickest way to solve these? We also have x is equal to a minus a. X minus a is equal to 6. What about minus 3 is equal to a minus 2p/√13? And I have x is equal to 3p/√13. So p is equal to √13 x over 3. So now I have minus 3 is equal to a minus 2/√13 times p, which is √13x over 3. So I also get a here. I get a is equal to x minus 6. So now I have minus 3 is equal to x minus 6 minus 2x over 3. And we're looking for x. So what have I got? I have x minus 2/3 x, which is just a third of x, would be equal to minus 3 plus 6, which would be plus 3. So x is equal to 9. So the velocity of the wind is equal to xi minus 3j. So we finally got there. The velocity of the wind is 9i minus 3j.